Back in 2007, I did some hydrogen experimentation and I wanted to bring this work back to life with the interest of using it in my off-grid mountain retreat. But first of all, a warning. Hydrogen is extremely volatile and you will get hurt. Don't try anything you see here at all. All of it is for information purposes only. Do not try this at home. As you can see, when you mess around with hydrogen, sooner or later, things will explode. Hydrogen generation is done by electrolysis, the process of running current through water containing an electrolyte. Water does not conduct electricity, or more precisely, pure water or distilled water. It's the impurities or contaminants that do. Never add salt to your water. This will produce a very toxic gas. We use sodium hydroxide as the electrolyte. A better and cheaper electrolyte is sodium hydroxide. This will cut down on the production of the red accumulation or anode slime and prolong the life of the stainless steel cells. Using stainless steel plates, an assortment of hydrogen cells were made, ranging in styles, distances, shapes, and sizes. They must be arranged in alternating fashion between positive and negative plates. One important thing to note with this configuration is that we are generating brown gas and not pure hydrogen, with the positive plates producing oxygen and the negative plates producing hydrogen. We also built an assortment of prototype hydrogen generators. We were so excited we even created a new logo. We even went as far as making custom power supplies, designed special electronics, and also got a hold of the latest and greatest in hydrogen production electronics. Not to mention the idea of rigging a motor and an alternator to maximize generation. We installed one of the hydrogen generators on a truck and logged the fuel consumption for several months. A continuation, there is a collection of the original tests that were done. Afterwards, I will go over my conclusions and a small controlled explosion. Please excuse the quality of the videos as they were recorded 14 years previously when I did not have access to better technology. The purpose of this test is to compare the 5-plate system we got here in comparison to the previous test. This one only has 2 plates, anode and cathode, with no dead cells, no dummy plates. So our current is higher. It's 8 amps versus 3 amps we had before at 4 volts. And as far as the production, I would say it's hard to guesstimate that it looks like it's possibly the same. It looks the same. It looks the same, and our current consumption is twice as, more than twice, almost 2.5 times greater than with the 3 plates installed. And gas production might be a little better, but not clearly. I would say that it is the same gas production as before, and we're consuming twice the current. Okay, here it is, same test. We have the 3 additional plates installed which are not, they're just neutral plates, and our current is 325 instead of the 8 amps we had before when we removed the plates. Now, hydrogen production does seem to be greater with the 8 amps. Without it does slow it down, slows the hydrogen production down, because it definitely looks like it's less than before. But our current draw before was quite a bit higher, was 8 amp. Now if we bring this one up to 8 amps with the power supply, we're going up. It's about 8 amps right there. So almost 6.5 volts. That's probably how it was. I mean, I don't notice a huge difference, but yeah, there definitely was probably equal amount now as before at the same amperage. Conclusion: I would have to analyze this. Okay, same as previous test, with the exception that we have now 1 neutral plate installed instead of 3. Current is at 483. Voltage a little higher than it should be. We'll lower the voltage to correspond. Okay, 4.5 amps. It's about 1.5 times, the current's about 1.5 times higher than with the 3 plates. Gas production is probably according to and directly related to our amperage in this case. Here we're testing plate distance. On the left side we have 1/2 inch gap between the plates. On the right side we have 1 inch. The one on the left is drawing about 2.9 amps. The one on the right is 1.39. And the one on the left that's drawing more current, just a little bit over twice as much, seems to be producing twice as much hydrogen gas. So that's your result for that test. We're going to compare now to, we're going to go to a different size now. Okay, plate distances comparison. Here we have one that has a 1/2 inch gap between the plates. The other one has 1/4. Now the temperature rises much faster on the right hand side. In 5 minutes it has risen from 83.4 to 88.1, and this one has gone from 83.3 to 86.2. So there is a big difference. The temperature does rise much faster on the closer plates. Now the one on the right is also drawing 4.3 amps, which is 1.3 more than the one on the right. The one on the right is drawing 3 amps. The voltage is the same on both of them. It's about 1159, 57, and gas production is close, but it is slightly more on the right hand side. Kind of hard to tell by the foam on top. It looks like the one on the right has a bit more. Trying to inspect the bubbles. It is A, this B. Now the plates are backwards, first positive and negative. That is the plate on the left here is the positive lead, I believe, and so that's the hydrogen there on the right. So we assume anyways, but the plates are, I should have switched polarity, but they're different, so you can see the movement on this one and the movement on this one. Which one's faster? They're new. Let's see, let's put them this way. This would be a good view right here. They're both plates, matching plates are on opposite sides. Actually, let me see if I follow this here. This here is our negative lead. So our negative is on the centers and positives on the outside. Okay, in this test, I'm testing plate distance, and this two different cells in here are both the same with an isolator, except the plate distance is one is 1/8 between the isolator and the plates, and then the other one is ½ inch. It's been running for just over 6 minutes, and the voltage on the right side is 5.7, on the left side is 4.93. They are both running at the same current, exactly at 0.91 or 0.9. The cloud looks like is greater at the cell at the left, but the foam on top seems to be slightly thicker on the right side, but the cloud that's created seems to be greater than the one on the left. So I'm not really sure which one's producing more. I would say the one on the left is, since the cloud, I think, is a better indication than the foam at the top. The electrolyte is exactly the same. There's no difference between the electrolytes. It's precisely there's from the same batch. So right here it looks like the plate difference, even though the current's the same, our voltage is a little lower on the left. Seems to be providing more hydrogen, if not the same. And our temperature is, we started with 77.8 on this side, and right now we have 78.1. This side was 77.6, and now is 77.9. So it looks like the temperature, as far as at just under an amp, is rising at about the same rate on both sides. We'll be trying the same test, and we'll be increasing amperage slowly. The units have been running now for over 20 minutes at a higher current of 1.85. The voltage on the right is 9.28, and the left is 7.44. As far as which one is producing more hydrogen, again, by the cloud appears on the left. There is more by the fog, but the suds on the top of the one on the right is a little bit higher. Now, as far as temperature wise, this one's running about 80.2, 80.3, and this one 8.6. So this one's a little bit higher. The one on the right is a little bit higher. Not much difference. So as far as plates being closer together, it seems like it doesn't create more heat. per, I guess, per creation or current. This test is to test two different types of cells. Both of them consume approximately 1.1 amps. Voltage is going to be the same. Water temperature is at 82.5, and I'm going to start them right now. Let's start the timer also here. This was more concentrated, but it's probably going to be about the same. They're both at 12 volts or close to it. I'm going to readjust that. Okay. And alright. It's been going about in a minute. One of them is dropping below where it should have been 2 amps. This is both of them combined right now, and it's showing that we're 172, so it looks like one of the cells has dropped off, or both of them have dropped off slightly. Our voltage is correct. As far as hydrogen production, seems like the one on the left hand side seems to have more activity according to the foam on the top. Look at them a little closely here. Yeah, an oxygen cloud is being built up on this one much better, so this one seems to be much better. We'll confirm the current draw in a minute. Check temperature. It's about the same when we started. They're both about the same. We're going to give it about half hour to see if it changes. Okay, this test is with the same two cells, two different type of cells. This test is about running the units in series. So each one gets exactly the same current. I balance the electrolyte to increase current. Each one was drawing about 1 amp before. Now both of them together are drawing 3/4 of an amp, and the production is a little lower. I will be bringing it up to 1 amp, and it looks like they will be running at the same capacity as they were before when they were standing alone, and combined they were drawing over 2 amps. They were drawing 2 amps and 2 1/4 amps. Temperature seems to be holding the same. They're climbing up at the same rate. This is a depth test. I'm going to turn on the power supply right now. They are two identical cells. Only difference is the depth. And we'll start also the timer. And we'll take a look, see if there's any difference in production. We'll check back in about 10 minutes. Okay, here we are after about 7 minutes. Current draw on the left side is 2.8 amps. Right side 2.7, about the same. Temperature is more stable on the right, and I'm not really sure if it's producing more than that. It seems like it is. It looks on the sides, and also the cloud created within the the chamber. Okay, here we have two different, or a new electrode. It's a negative, positive, negative electrode, and our standard positive, negative electrode on the left. Seems like it's producing probably about 75% more than the dual plate. This triple plate is producing probably about 75% more. As far as current consumption, that's something I got to look into. It looks like it's drawing quite a bit. Temperature wise, temperature is rising. It's 84.6, 82.5, so there is a difference in production. Also notice that most of the hydrogen is coming from the edges, not really from the middle of the plates. It seems like the edges are the ones that produce the most, and what you see rising in the middle of the plate is what's coming from the bottom edge. So we'll from this we'll be working on a new design. Okay, this one here is straight from the battery. Is 12 volts and is drawing 1 amp. And from the same battery, we're running across this power converter, converting our same 12 volts that are feeding our unit, and we're converting it over to 110 and rectifying it, going to DC. Actually it's 126, rectifying it through here. And the same amount as using this unit is using 1.2 amps on idle, and it increases by about an amp when we hook up our DC converter to run this unit. So this one is also drawing 1 amp at 12 volts through the converter, giving us about 0.1 amps at 125 volts. You can see that there's very little hydrogen generation, and for the same, it works out to be about 12 watts of power being consumed here at 125, and this is 12 watts of power at 12 volts, 1 amp, and we can see there's a huge difference. And this is again running through the same battery, same power supply. One of them is converted to 125 through this converter. The current is being regulated by the amount of electrolyte in each cell to limit it to the corresponding wattage, which will be about 12 watts each. Our temperature is about the same, maybe probably increasing a little faster, possibly in this one. Can't really tell with the gun. I'll try it again here and see if we can get a reading. That one is 79.1 after about 5 minutes, and this one was actually higher. So this one's producing less hydrogen. It looks like most of the energy is actually being converted into heat. And over here on this side is slower. So looks like our best way, according to this test, is using 12 volts, lower voltage, higher current. Okay, what we're testing today is 12 volt, 1 amp versus 4 volts, 3 amps. It's actually a little higher than 3 amps. Our starting voltage was 12. It's dropped down a bit. That's being fed by a set of batteries. This one's being fed by a power supply at 4 volts. And we'll put our meter, see how that's doing. Okay, we have 3.96 volts at 3.19 or 8 amps. That's our production for low voltage, high amperage, and this is our production for I guess 12 volts battery voltage and 1 amp. Same wattage. We have 12 watts of power being fed to each one. Our starting temperature was the same on both of them, which was I believe it was 77.6. So we'll check that in a minute. And so you can see the production on the lower voltage is much greater. It's, I would say, at least 3 times more than it is on the 12 volt. So we got again, each one is consuming the same amount of power, 12 watts, and our lower voltage, like we did on the other test, is showing that current is definitely more important than voltage, and we're going to try to see if we have any temperature change. It's been on for 3 minutes, coming up on 3 minutes now, and we'll see what our temperature readings are. We got 78.3 and 78.6. It seems to be higher at this end. 78, 78.5. So we'll leave it for a little longer and we'll check back to see how our temperature is doing. Okay, it's been just over 13 minutes, and we're running the 12 volt 1 amp versus the 4 volt 3 amp test, and what we're going to see is temperature. The temperature on this side here, we have 80.3, and this side is 79.9, and this is 80, so it's 80. It's hard to tell depending on which part of it. You have more hydrogen and air bubbles on that side. We got 80. Try to look at the plates. 80.2, 79.4. So temperature wise seems to be about the same. I guess I should get a different probe to test temperature here, but it seems to be still, this side seems to be a little cooler than this side, but it seems that that's the way almost since the beginning. The neutral plates don't seem to be doing. Right here we have a test that's predicted, both running the same current, 5 amps, they're in series. You have a simple 2-plate 1/8 inch on the left, and our 3-plate system on the right. Both producing the same. The right has about 14 volts, left has about 3.9. Okay, here's a plate test. We have a simple 2-plate 1/8 inch spacing with a negative, positive, negative configuration on the right, and I'm going to fire it up right now. Okay, they are both going to be drawing exactly the same current. The voltage will be higher on the one on the right. they're drawing about 5 amps. Unit on the right has about 11 volts, and unit on the left has about 4 volts. Production, I would say, is pretty even, and we'll check back in about 10 minutes. It's been about 4 minutes, and the water level on the right seems to be a little higher, but that's due to the size of the plate of the cell. The cell is much larger, so it brought up the water level higher. Both electrolytes have been made from the same batch. They're exactly the same, and they had exactly the same amount. Both these units are drawing 5 amps. Voltage is higher on the one on the right, and the sides and the top are a good indication as far as how much is being produced. I would say that both of them are producing exactly the same, and it's a guarantee that the one on the right is temperature is going to be higher. Temperature is 98.2, and this 92.2, 98.2, so it's much higher over there because the voltage is higher. Current is identical in both units. Okay, this is a pressure test, hydro production and pressure, where I'm going to start the count right now. I'm going to fire it up. I'm going to watch our gauge. Okay, start that now. Okay, we're drawing about just a little over 6 amps. Our clock is at 10 seconds. So far, we see nothing. No, the needle's starting to move now. At 20 seconds, we have over 20 seconds. We have over a pound and a half, and our pressure is climbing slowly. We're making a bomb here. Hopefully we won't be flying across the room here. I'm not even wearing safety glasses right now. We don't know what this is going to do, but we're only going to let it get up to about 10 at the most. Okay, we're at 1 minute, and that's about just a little over 6 amps again. Our container here is probably pressurized good up to probably around 15. I'm not sure if I'd be able to do more than that because of mainly the seal where the wires come out through. The end that's my weak link in the system right now. Okay, we're at a minute 36 seconds, and we're at 7 psi. Minutes, 5 seconds, almost 10. Let's see how long it takes to get to 10, and we got 10 at 2:20, and that's the end of our test for now. Okay, it's been almost 6 minutes, and we're above 20 psi. We get some safety glasses on, and we verifying the amperage, which is 6 amps. Still holding the same. We probably dropped slightly. I think we started off a much higher, so we're going to check, see if our current drops down. Not sure if our production drops down when the pressure increases. We're up to almost 25 at 6 minutes 10 seconds. Again, there is a slight leak in this here, and we're losing pressure right at this point, so I'm sure it's actually gaining faster than that. Okay, this is our fire suppressor or fire arrestor device test. There's a device. Over here we have our safety tester. This is our bubbler right here, and the cover is put on lightly and sealed with Vaseline to prevent gas leakage. It's very little airspace in there, so that seals nicely there. This is to catch the cover when it explodes. And down here we have our cell HHO generator and our unit to keep it contained in case of an explosion. We had a couple of those already. This keeps the mess down to a minimum, and the cover here keeps the debris or shrapnel inside. Okay, then we have our torch over here just to keep it going. Now we're going to see what happens when we apply a flame to it without the suppressor. Okay, we got the unit running at about 5 amps, and there should be enough gas in there to test it. Now this is without a fire suppressor. That's exactly what happens without a suppressor for a spark. And there's a production right there. Now we're going to put the arrestor in there and try it again. Okay, that's just with the suppressor installed. The torch is lit.
And now to summarize our findings. 2 volts should be kept between plates, and current flow determines production. Controlled by plate distance and electrolyte concentration. Ideal plate spacing appears to be 1/8 inch. We learned that the electrolysis process is capable of compressing the hydrogen-oxygen gas without a compressor. We also learned that hydrogen and an open flame are not a good combination. In a hydrogen car, the hydrogen is directly converted to electricity without exposing it to a spark. Saying that hydrogen is clean energy is like saying a battery is clean energy. Hydrogen is not really a fuel, but an energy storage means, and a very inefficient one at that. You basically lose 60% of the energy required to produce it. My reasoning for looking into hydrogen again is to capture excess energy once my battery banks are tapped off or fully charged, and then use it as a cooking or heating fuel, or at least that's the idea.
Okay, we have here another prototype. This one is drawing about 18 amps. It's been running for about 4 hours. And it produces 60 liters per hour. Temperature has, we'll double check that right now, the temperature after 4 hours is about 104. I think it's 115, I think it's 116. I think this is their pretty much a warmer cell I've been tracking. So this one's it's about 116.8 or 117, and that's after 4 hours of running at close to 20 amps. The gauge does jump around according to when the charger kicks in. As you can see there, it's actually jumping all the way up to almost 25 amps. But in the average is about 20 amp average. You can see what our production looks like here. So we'll let it run for another 2 hours and see how high our temperature goes. So you cool that, it's bubbling. Yep. Fill that with water.
So I can actually see it.
Now she's starting to pump the water out to put the gas in.
She's doing it very quick. Just about done.
It's telling it's 36 seconds to a minute, but that's start of when you started the truck.
Yeah, she's starting it all the way up. Alright, you got everything in there. Keep it like this, she's going up top.